first we have a definition, mutually exclusive. That's sometimes called disjoint. That means there's no common outcomes. It's two things that cannot both happen. For instance, can you be in my 5th hour class and have second lunch shift? No. If you're in my 1st hour lunch, or my 5th hour class, you know you have first lunch shift. So it's impossible for you to be in the second. So those would be disjoint events. Second lunch, my 5th hour class. They have nothing in common. Nobody could be in both groups. What that means in terms of probabilities, we could say that they cannot both occur, so the probability of both things happening, so I'm just going to say a probability of E and F, probability of both of them happening is 0. It's impossible for both to occur if we had disjoint events. All right, so if I'm calculating probabilities for disjoint events, then they have no overlap, so we can use the addition rule and just add the individual probabilities together. So if I wanted the probability that you were in my 5th hour class or you had second lunch shift, I add the probability you're in my class plus the probability you had second lunch. So if they're disjoint, we can just add those individual probabilities together. So let's take a look at this one. We have a probability model that shows the distribution of the number of rooms in housing units in the United States. So here's the number of rooms they might have and the probability. Verify it's a probability model. What were the requirements to be a probability model? You have to add to 1, and every probability has to be between, okay. So all of them are between 0 and 1. Add it up real quick and make sure it does add up to 1. It does? So this is in fact a probability model. Alright, so if I want the probability that a randomly selected housing unit has 2 or 3 rooms. Right. Is it possible for the unit to have both 2 rooms and 3 rooms? No. So these are disjoint. There's no overlap. There's no housing unit that got double counted and fit into both groups. So all we have to do is add the probability of 2 rooms plus the probability of 3 rooms. So what's the probability of 2 rooms? Plus the probability of 3 rooms. And if we add those together, so there's a 12.5% chance the unit would have either 2 or 3 total rooms. Alright, so C. What's the probability that a randomly selected housing unit has 1 or 2 or 3 rooms? So what do we have to do? Basically the probability of 1 room plus the probability of 2 rooms plus the probability of 3 rooms, so you're just adding those together. And we get Are we okay with those? But this requires that our events be disjoint. And that is not always the case. What if I wanted the probability that you play softball or cross country? Are those disjoint? No. Ella here would ruin that, right? She's in both. So we couldn't just add those individual probabilities. What happens if I add those two probabilities? Right, it's a little, it could, depending. So if I were counting the number of people in softball, so if I were counting the number of people in softball out of our school, plus the number of people in cross country out of our school, what happens to those people that are in both? They got double counted, didn't they? I counted them in both groups, so then the probability really isn't accurate anymore. So how would I fix that if I've double counted them?
Subtract the people that were double counted.
Okay. We would have to subtract off the ones that got double counted, so we had an accurate probability. So that's our general addition rule. So if it's disjoint and they have no overlap, we can just add our probabilities together. But if they are not, then the rule becomes the probability of E plus the probability of F minus the probability of E and F. Remember I told you if they were disjoint, the probability of E and F is what? 0. So we could really use this rule every time. And if they're disjoint, we know that final probability is 0. Alright, so let's take a look at this one. So I'm going to roll 2 dice. Okay? And I'm going to look at these events. Event E is the first die is a 2. Event F is the sum is less than or equal to 5. So if I want the probability of E or F, would these be disjoint events? Why not?
Some would be, like it could be a 2.
Okay. Could I have a 2 on the first one and have 2 dice that add up to less than 5? Yes. So they are not mutually exclusive. So we have to use our general addition rule. Okay, so the probability of E or F. That's the probability of E plus the probability of F minus the probability of E and F. Alright, so the probability of E. That's the first one getting a 2. So we know from yesterday probabilities, we are dividing the number of outcomes we want out of the total. I put this diagram up here. How many total combinations are there? 36. 6 options for the first, 6 options for the second. So 6 times 6 is 36. And we can see that just by counting. Okay, so in how many of those is the first one a 2? Those options, my first die was a 2. So that's 6 out of 36. Plus, F was the sum is less than or equal to 5. So how many of these were less than or equal to 5? So let's start counting. Okay, this is 2, 3, 4. Would I count this one? We said less than or equal to, so we want to go ahead and count it, but we couldn't count any of these. They're too much. This is 3, 4, 5. 4, 5. That one adds up to 5. Did I miss any? So how many options worked? So we have 10 out of 36. But how many did I double count?
3.
This one got double counted, this one was double counted, and that one was double counted. So we have to subtract off those 3. Right, so tell me what our probability is. Let's go ahead and give the decimal. that means there's slightly over a 36% chance that either we roll a 2 with the first or the sum is less than or equal to 5. Any questions on that example? Alright, I guess I should maybe ask before I do this next example. Do you guys know what a deck of cards is like? Have you ever played with a deck of cards? Okay, so you know how many suits are in a deck? 4 different suits. Okay, how many? So you know for each suit you have ace through 10, jack, king, queen, so forth. Okay. So suppose a single card is selected from a standard deck. Compute the probability of drawing a king or drawing a diamond. So I want the probability of king or diamond. And I'm going to start using this notation kind of to follow along with our formulas because for the next week or so, we're going to keep adding to this. And while today you can probably calculate a lot of these without writing out a formula, as it gets more complicated, notation will help you a lot. So could there be overlap here? Can we have a card that is both a king and a diamond? Yes, so we need to use our general additional. So we need the probability of king plus probability it's a diamond minus the probability of it being both. Alright, let's say excluding jokers. How many cards are in the deck?
52.
52. How many of those are kings?
4.
Alright, out of my 52 cards, how many of them are diamonds?
30.
Out of those 52 cards, how many are both a king and a diamond? So if we add that up, 16 out of 52, which is what? 4 over 13 if you want to keep it in fraction form. And if you went to decimal, you would get Are we okay with those? Let's try one with a little bit different setup. So we are going to look at this table. So we are looking at residents in a particular area, and we have counted how many are male, female, and their marital status. Okay? So if I want the probability a resident is a male, what am I going to have to do first if I'm going to find any probabilities? Add them all up. We need to know what our grand total is. How many people are we looking at? Okay. Let's add up. I'm going to go ahead and add up my males and females and we'll double check. Let's take a grand total of 251.3 million. So if I want the probability a resident is male, this is more like yesterday, it's just a straightforward probability. How many males do we have? You just add up your male column. Out of how many total?
51.
Right? Can we get? $7.5 approximately. Alright, B, the probability of resident is widowed. So what do I have to do? Add up the widowed, so we need to put those two together. And that gives me 14.3 out of my grand total, 251.3. So we get 0.0569. Is that considered unusual? You're saying no, Izzy. What's the break for unusual?
Has to be lower than or equal to 5%.
Right. Yesterday we said an unusual event is probability less than 5%. So this one's bigger than 5%, so it's not unusual. All right. Last one. Well, not the last one. Sorry. Last one I'm going to do with you, then I'm going to make you try the next one on your own. The probability a resident is widowed or divorced. Okay, can we have overlap in this one? In this particular table, can they fit in both categories, or did I separate those two? They're separated. So how would I find the probability of widowed or divorced? Yep, we just have to add the two together. There's no overlap, so we don't have to subtract anything. So widowed, we had 14.3 over the 251.3. Divorced, so if we add those in, that gives me what's wrong? What are you debating? If you could be both? Is that what you're debating? So let's say this table is doing their most recent marital status. How about that? So, like your spouse.
Then you're not.
Died on October 2nd.
Soon to be divorced.
I didn't know I was putting such a controversial question up here, but I appreciate the deep thought. Alright, why don't you guys try the next one? You're gonna have to think a little bit more though, because this one we could get it.
This isn't actually.
So, could they be both male and widowed?
Yeah.
Okay, so we have to do the probability of male plus the probability of widowed minus the probability of both. Okay, so probability of being male. There are 122.5. I have 251.3. You might have used these decimals from A and B, but you could have a little rounding error if you do that, so make sure you're showing your work if that's the case, so I know where it came from. Widowed, we had 14.3 out of 251.3 minus both. We want to know how many are male and widowed. So we have double counted those 3.1. All right.
What happened?
Did you just plug it in your calculator wrong?
That's very valid, because I do that all
You
the
had the
time.
right word.
I just added these up and divided it by 20.
Okay, but you never subtracted off the
Yeah.
3.1.
I know
But
what
that's,
it is.
I only do that if it affects both of them.
Well, so if you have double counted, if anybody fit into both groups, that means we count them twice, so we need to subtract them.
Okay.
And if you
Good. Other questions? All right. One more term for today. So we talked about the addition rule. The last piece of this today, we want to throw in complements. So a complement is anything that is not in our set. So if I'm looking at all of our high school students, and my set is the students in my classroom, what would be the complement of that? So it's the rest of the students, all the students that are not in my classroom. So if we put the two together, the complement and the set, we should have everybody. So that would add up to 100% if we took those individual probabilities. So the easiest way to find a complement would be to do 1 minus. Okay, everybody either fits in one group or another. If you think about it, like here's my whole group. Let's say this is event E. Everyone not in E is the rest of the box here. The notation for that, you might see an E with, it looks almost like an exponent, a superscript, a C. Sometimes it's also written with a bar across the top, so it really just depends on the textbook which one you will see. They both mean complement, so it's just 1 minus. I typically use the bar more. Your textbook likes the C, so you'll be exposed to both. So just 1 minus our probability. Just like everything else, this is on your formula sheet. You would have to flip to the second page now, and so it's the first bullet on the top of that second page. So we're just going to practice some more probabilities. I think I have, 3 or 4 slides left, and then I'll give you guys time to try some on your own. So according to the American Veterinary Medical Association, 31.6% of American households own a dog. What's the probability that a randomly selected household does not own a dog? So what would I do? So either you own a dog or you don't. There's no third option. So that would give me 684. Or you could say 68.4%. Could I say that the complement of owning a dog is owning a cat? No. A set and its complement have to account for everyone. So everybody has to fit in one of those two. Not everybody owns a dog or a cat. Okay, so we have to be careful there. All right. Let's look at this table. So this data is giving me travel time to work for residents of Hartford County, Connecticut. What is the probability a randomly selected resident has a travel time of 90 or more minutes? What am I going to have to do here? Add them all up. Testing your calculator skills here. Double check me. I got 393,186. Okay. So tell me the probability that the travel time is 90 or more. What would I do? Divide what? What would be the top?
4,395 divided by exactly.
Good. And we get 0, 1, 2, 4. What would I call that event? Unusual. Very good. Okay. Then, if I want the probability that a randomly selected resident will have a commute time less than 90 minutes, we have two ways of doing that. Less than 90 minutes, isn't that any of these other rows? So we could go through and add up all of those numbers divided by our total, and that would work. What's the alternative?
Subtract.
Yeah, we could just do the complement. We just found the probability that it was more than 90. So to do the less, we just do 1 minus the answer we got. And what do we get? So very likely that your time is less than. Any questions on what it means to be a conflict? The last slide for today. I wanted to practice if you could find these probabilities without actually having a scenario to apply them to. Okay, so this is really just relying on our ability to use our formulas and plug things in carefully. So the first one, I gave you the probability of A, probability of B, probability of A and B. I want the probability of A or B. You have this handy dandy formula sheet that you get for everything. Is there any formula that involves all 4 of those pieces? Yeah, which one is that? Pointing at it. The general multiplication, or general addition one, excuse me. So that one says the probability of A or B is probability of A plus probability of B minus probability of A and B. So we just plug in stuff. Probability of A is 0.4. Probability of B is 0.5. Probability of A and B. So we get 0.8. Probability of A or B. Alright, but just like anything else, we could solve equations with these. So we might have to move terms around. So the next one, I'm still giving you all the same components, but this time I told you the probability of A or B. We're finding the and. So the formula, probability of A or B, probability of A plus probability of B minus probability of A and B. Very helpful to write out what formula we're using. Plug in what we know. So the probability of A or B, 0.7 equals the probability of A, 0.4 plus the probability of B is 0.5 minus the probability of A and B. Okay, so if we subtract over the 0.9, we have a negative 0.2 equals a negative probability of A and B. Divide by the negative, so the probability of A and B is 0.2. Quick check, what do you know about every single probability at the end? What kind of number should it be? Has to be positive, and it has to be between 0 and 1. So if it's not, you made a mistake. Last one. So still using the same formula. So the probability of A or B is 0.9 equals the probability of A, 0.4, plus the probability of B, which we do not know, minus the probability of A and B is 0.1. So please, my point with these, don't just try to look at it and guess the answer. Just write it out. The math isn't hard. You just have to plug things in appropriately. So 0.4 minus 0.1 is 0.3. subtract that over, so the probability of B is 0.6. Any questions? So I want to give you guys time to work. Same rule as yesterday on the problems where it says find and interpret the probabilities. You don't have to do the interpretation.